let us solve some problems based on the applications of trigonometry. First problem, a tree breaks down due to an accident and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Let us find the height of the tree. So, let's now see how to solve this problem. Let us draw the figure according to the question. So, let A be the point where the tree was broken and C be the point where the top of the tree touches the ground, making an angle 30 degrees from the foot of the tree. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. So, if we add both AB and AC, we get the height of the tree. As mentioned, BC is 8 meters and angle C is 30 degrees. We get tan theta by taking opposite by adjacent, which is equal to AB by BC, which is equal to H by 8 meters, which is equal to tan 30 degrees. We know that tan 30 degrees is 1 by root 3. Therefore, we substitute the same. Solving for H, we get 8 by root 3. So, now that we have found out the H value and base value is already given, can we find out the AC value with the help of cos theta? Yes. Cos 30 degrees is given by BC by AC, which is equal to 8 by AC. Now, substituting the cos 30 value, that is root 3 by 2, is equal to 8 by AC. Rearranging, we get AC as 16 by root 3. Now, let us see what is the height of the tree. Height of the tree is given by AB plus AC, which is equal to H plus AC. Substituting, we get 8 by root 3 plus 16 by root 3 is equal to 24 by root 3. Now, let us rationalize. That is 24 by root 3 into root 3 divided by root 3, which is equal to 24 root 3 by 3. That is 8 root 3. Hence, the height of the tree is 8 root 3 meter. Let's consider another problem. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance that he walked towards the building. In this particular type of question, we first need to draw the diagram to get a clear picture of the scenario. We need to observe the triangles formed in the question and then use the trigonometric ratios to find the required equations and find the distance the boy travelled. Let height of the boy be AB, which is equal to 1.5 meter. E is the point at which the building is standing perpendicular to the base. And let distance BD covered by the boy be X. Therefore, BD is equal to AC is equal to X. Let the distance of the building from the point where he stopped by be Y. Therefore, DQ is equal to CE, which is equal to Y. In the figure, PE is equal to 30 minus 1.5, that is 28.5 meter, which is the distance of the top of the building to the head level of the boy. Now, the angles where he started walking and stopped walking are 30 degrees and 60 degrees. On observing triangles PAE and PCE, we get in triangle PAE, tan 30 degrees is equal to PE divided by AE. Substituting tan 30, we get 1 by root 3, which is equal to 28.5 divided by AC plus CE, which is equal to 28.5 divided by X plus Y. Rearranging X plus Y, we get 28.5 root 3. Let's consider this as 1. Now, in triangle PCE, tan 60 degrees is PE by CE. Substituting tan 60, that is root 3, which is equal to 28.5 divided by Y. Solving for Y, we get 28.5 divided by root 3. Now, let's substitute Y in equation 1. We get X plus Y is equal to 28.5 root 3. Now x plus 28.5 divided by root 3 is equal to 28.5 root 3. Solving for x, we get x is equal to 28.5 root 3 minus 28.5 divided by root 3. Taking the LCM, we get as root 3. That is 28.5 root 3 into root 3 minus 28.5, divide the whole by root 3. 28.5 into 3 minus 28.5 divided by again root 3. That is, we get x is equal to 85.5 minus 28.5 divided by root 3. Subtracting the same, we get 57 by root 3. Now, let's rationalize the same. That is, 57 by root 3 into root 3 divided by root 3 gives us 57 root 3 by 3. That is 19 root 3. Therefore, 19 root 3 meter is the distance the boy walked towards the building. As observed from the top of a 75 meter high lighthouse from the sea level, the angles of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. From the question, we identify that this is a problem related to the angle of depression, and let us draw the figure accordingly. Let A be the topmost point of the lighthouse, and let one ship be at the point B at 30 degree when viewed from the top of the lighthouse, and let another ship be at the point C at 45 degree when viewed from the top of the lighthouse. Lines PA and BD are parallel and AB is the transversal. Therefore, angle ABD is equal to angle PAB because they are alternate angles. So, angle ABD is equal to 30 degree. Similarly, lines PA and BD are parallel and AC is the transversal. Therefore, angle ACD is equal to angle PAC because they are alternate angles. So, angle ACD is equal to 45 degree. Since lighthouse is perpendicular to the ground, angle ADB is equal to 90 degree. In triangle ACD, tan 45 degree is equal to AD by CD. Substituting tan 45, we get it as 1, which is equal to 75 by CD. Solving for CD, we get it as 75 meter. Similarly, in triangle ABD, tan 30 degree is equal to AD by BD. Substituting tan 30, we get it as 1 by root 3, which is equal to 75 by BD. Solving for BD, we get it as 75 root 3 meter. Now, we can write BD as BC plus CD, which is equal to 75 root 3. Substituting CD, that is BC plus 75 is equal to 75 root 3. Solving for BC, we get it as 75 in brackets root 3 minus 1. Solving it, we get it as 54.9 meter. Hence, the distance between two ships is 54.9 meters. A 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meter from the ground. The angle of elevation of the balloon from the eyes of the girl at an instant is 60 degree. After some time, the angle of elevation reduces to 30 degree. Find the distance travelled by the balloon during the interval. Let us see how to approach this problem. In triangle ACE, AE by CE is tan 60 degree. That is 88.2 minus 1.2 divided by CE gives us root 3. Solving for CE, we get as 87 divided by root 3 meter. Similarly, in triangle BCG, BG by CG is equal to tan 30 degree. As we know, tan 30 is 1 by root 3. Therefore, 88.2 minus 1.2 divided by CG, which is equal to 1 by root 3. Solving for CG, we get as 87 root 3 meter. Distance travelled by the balloon is EG, which is equal to CG minus CE. That is 87 root 3 minus 87 divided by root 3. Here we observe that the LCM is root 3. Therefore, 87 root 3 into root 3 minus 87, divide the whole by root 3. That is 87 into 3 minus 87, divide the whole by root 3. That is 261 minus 87 divided by root 3. Again we rationalize. That is root 3 is LCM here. So we rationalize and get it as 174 divided by root 3 into root 3 by root 3. That is 174 root 3 by 3. Solving the same we get as 58 root 3 meter. Hence, the distance travelled by the balloon during the interval is 58 root 3 meter. Now let us consider another problem. The angle of elevation of the top of a tower from a point on the ground, which is 30 meter away from the foot of the tower, is 30 degree. Find the height of the tower. Let us see how to approach this problem. Given the tower is 30 meter away from point A, given angle of elevation of top of the tower is 30 degree. So let the height of the tower be x. Therefore, tan 30 degree is equal to BC by AB. We know that tan 30 is 1 by root 3. Therefore, 1 by root 3 is equal to x by 30. Solving for x, we get it as 30 by root 3. Now let's rationalize. That is 30 by root 3 into root 3 by root 3. That is 30 root 3 by 3. Solving same for x, we get it as 10 root 3. Therefore, the height of the tower is equal to 10 root 3, which is equal to 10 into 1.732. Solving the same, we get as 17.32 meter. Hence, the height of the tower is 17.32 meter. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meter away from this point on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and the width of the canal. Solution for the same is as follows. In the figure, let AB be the tower and C is the point on the other side of the canal directly opposite to the tower. And let D be the new position after changing the elevation. Let AB is equal to h, BC is equal to x and CD is equal to 20. From right angle triangle ABC, we get tan 60 as AB by BC, which is equal to h by x. We know that tan 60 is equal to root 3. That is, root 3 is equal to h by x. Solving for x, we get it as x is equal to h by root 3. Let's consider this as 1. From right angle triangle ABD, tan 30 degree is equal to AB by BD. We know that tan 30 is 1 by root 3, which is equal to h by x plus 20. Taking x plus 20 on the left hand side, we get x plus 20, which is equal to h root 3. Consider this as 2. We have x is equal to h by root 3. Now h by root 3 plus 20 is equal to h root 3. Now rearranging, we get h root 3 minus h by root 3, which is equal to 20. Now taking the LCM as root 3, we get h root 3 into root 3 minus h, divide the whole by root 3, which is equal to 20. That is 3h minus h divided by root 3, which is equal to 20. That is 2h by root 3, which is equal to 20. Solving for h, we get h as 10 root 3. Now from equation 1, x is equal to h by root 3, that is 10 root 3 divide the whole by root 3, which is equal to 10. Therefore, the width of the canal is 10 meter and height of the tower is 10 root 3 meter.